Hello everyone, I am Mr. Zilich, and today we are talking about trig ratios. So we have three trig ratios that we're going to talk about today: sine, cosine, and tangent. And so if you see here, I can spell them out for you: sine, cosine, and tangent. And we're going to be working with these. We're going to be working with these with the right triangles and developing, again, ratios. So it's going to be a fraction, and we're going to get some numbers with these trig functions. So there's a nice phrase in mathematics called SOHCAHTOA. You kind of see it represented here. So SOHCAHTOA. And we already went over what the S, the C, and the T stand for. And over here to the right, I gave you guys what the O stands for. So the O stands for the opposite leg of the triangle. H stands for the hypotenuse. And A stands for the adjacent leg. So once again, O is the opposite leg, H is the hypotenuse, and A is the adjacent leg. And it's all based upon which angle you are looking at. So here on the bottom right, I have a nice little triangle here with angles A, C, and B. And if you notice, the side opposite of the angle is labeled as such with the letter. So this is side C, side A, and then side B is opposite of angle B. So how these trig functions work is we take an angle such as A and we find the ratio. So we go back over to the SOHCAHTOA over here to the left, and for any sine function, it's going to be opposite over the hypotenuse. And so for our triangle here, that side would be A divided by C, which is the hypotenuse, which is the side opposite the right angle. So again, sine A would equal A over C. And then if I take my different angle, angle B, I would have the opposite side of B, which would be side B, divided by the hypotenuse, which once again is C. Similarly, we have cosine, and so we look up here to the top left. We have cosine is A over H, or the adjacent leg over the hypotenuse. And the adjacent leg is going to be the leg that touches the angle, but is not the hypotenuse. So it can't be the hypotenuse. So for cosine of A, so we're looking at angle A right here, the adjacent leg again is not the hypotenuse, but it's the other leg that touches the angle. So we have B. B would be the other leg that touches angle A. So for cosine A, we have B divided by the hypotenuse, C. Then we have cosine of B, and that is equal to A divided by C. So again, we have angle B, the adjacent leg is A, and then divided by the hypotenuse, C. Finally, we have the tangent, and that is represented as a ratio of the opposite over the adjacent. And so once again, we're looking at angle A and angle B. And so we have the tangent is A. So again, angle A, the opposite side is side A, divided by the adjacent leg, which for angle A is B. So for tangent B, we have angle B. We are looking at angle B, and then that equals the opposite side, which is B, divided by, the adjacent leg. So we have the opposite side B divided by A. So that is kind of the nice little general format of the trig ratios. Again, they are ratios, they are fractions, and we can use any numbers to plug in, such as, for real quick, let's say A is 2. How about let's A 3, B is 4, and C is 5. So if I find sine A, I look at angle A, I look at the opposite side. So for this instance, sine A equals the opposite side, which would be 3, divided by the hypotenuse. Cosine of B would be the adjacent over the hypotenuse. And so then we would have 3 over 5. So notice how these are the same, even though the functions are different. So again, the adjacent over the hypotenuse. And finally, the tangent of A would be the opposite of A, which is side A, which would be 3, divided by the adjacent, which is 4. So again, that wraps up. And as always,
this is a Mr. Z production.